Today we're going to talk about the area formula for trapezoids. So far we've learned the area formula for all our parallelograms. Now we're going to learn them for all our trapezoids. Since there are two main types of quadrilaterals, we need to know our area formula for the trapezoids as well as the parallelograms. So we're going to start by learning where the trapezoid formula comes from. And this is just to help you remember the trapezoid formula. If you don't totally get it, it's okay. You can just memorize the trapezoid formula. So if you look at a trapezoid is half of a parallelogram. And you can see that the two bases, when a parallelogram is split in half, the two bases, of course, are not congruent. We have base, that's called base 1 and base 2. It's base sub 1 and base sub 2. So instead of an exponent, it's called a sub. Okay. So we have base of 1 and base of 2. Those are the sides. Our bases are the sides that are parallel to each other. Our legs are the sides that are not parallel to each other. So height is always the perpendicular distance between our bases. We saw that with our parallelograms. The height is going to be the perpendicular distance between your two bases. And the height can be drawn outside your parallelogram. It can be drawn inside your parallelogram. It doesn't matter, but it's that distance between the two bases, the two parallel sides, that's perpendicular to both of them. That's how we recognize the height. So in this diagram, I have the height drawn in red, and it's perpendicular to the top and bottom of our parallelogram. This height is also going to be the height of our trapezoid, because the height is going to be the perpendicular distance between the two bases of our trapezoid. So it's the same height for our trapezoid as it is for our parallelogram. Well, you'll notice that this base 2 in the top is going to end up being the same thing as the base 2 in the bottom of the other trapezoid. So if we look at this other trapezoid, it's a flipped upside down version of the first trapezoid. So the base sub 2 in the first trapezoid is now at the bottom. And so the base of 1, when the trapezoid's flipped upside down, ends up going to the top of our second trapezoid. So the formula for the area of one of these trapezoids is going to be half the area of our parallelogram, which is base times height. Only for our base, our entire base, is going to be base sub 1 and base sub 2 added together. So this is really base sub 1 plus base sub 2 to give us our entire base of the trapezoid, of the parallelogram. So the base of our parallelogram is these two little bases added together. So I have height times the two bases added together. Gives me the area of the whole parallelogram. So base of 1 plus base of 2 is really what the whole base is, times height. And then we know that our trapezoid is really just half of that area. So our trapezoid formula is half the sum of the bases plus the height. All right, so here is a trapezoid. So in this trapezoid, I see the bases, base 1 and base 2. Now I could reverse this. I could call this one base 2 and this one base 1. It doesn't matter a bit in the world which one's base 1 and which one's base 2. What matters is that we have two bases that are different lengths. And those are the two sides that are parallel to each other in a trapezoid. We know we have one pair of opposite sides parallel in a trapezoid. The one pair of opposite sides that are parallel are called bases. We'll call one of them base 1 and one of them base 2. The height is the perpendicular distance between the two bases, which can be drawn inside or outside your trapezoid. Doesn't matter. But it's perpendicular to both bases. So that's how you recognize the height. We know the area formula for a trapezoid is 1/2 the sum of the bases times the height. because we just saw how that was derived. Again, if you don't understand how it was derived, it's not a big deal. You just need to know how to use the formula. So let's look at some examples. Now here's a trapezoid that is not an isosceles trapezoid. It's just some random trapezoid. So the first thing we need to do is identify all the parts that are in our area formula. First, we need to identify the bases, which are the sides parallel to each other. So the bases are 14 and 8. It doesn't matter which one you let be base 1 and which one you let be base 2. That's completely irrelevant. The important thing is that we're adding them together. 8 is our height because it forms a right angle with the two bases. We'll put the number 8 in the place of h. Now, the 8 that's our height could have been drawn where it is drawn, or it could have been drawn up here where we see our two right angles. Either place is fine. It's still our height. Now we're going to put this straight into our calculator. We're going to put this straight into our calculator. You can use 0.5 or 1/2. Make sure you use your parentheses and put it straight in. One step, and you will get 88. We're going to use U for units, so it's 88 units squared. I use U when they don't give us the units. So here are the steps, nice and neat right here. So we have our formula, area equals 1/2 the sum of the bases times the height. So we know that the two bases are the sides that are parallel to each other. Well, 3 and 5 are the sides that are parallel to each other, so I'm going to put that in the place of b sub 1 and b sub 2. And then the height is going to be the line that's perpendicular to the side that's 5 and the side that's 3. And so the height is going to be 4.5. Now we're going to put that straight into our calculator to find the answer. So when we put all this into our calculator, we end up with the area equaling 18. And for units, if we don't have units, we can just write U and square it, because with area, that's how much we have inside. It's always units squared.